Hi, it's Carly McAvoy. I wanted to do a quick projectile motion application. A model rocket is fired straight up from the ground. The height s of the rocket in feet is a function of time, and this can be modeled by the function given s of t equals negative 16t squared plus 160t. Now, the height is given as the letter S. That's along our vertical axis, and our time goes along our horizontal axis. And it should make sense that if we're starting here and we're firing a rocket, it goes up and it comes down. And so there's a couple of questions. When will the rocket be 384 feet from the ground? Well, that's our height. And so if we want to know something about the height, that's what we want to plug in over here. So we would say, well, we want 384 feet in height, and so then we can solve to find out what the time will be. That's the when it will hit that height. So 16t squared and then plus 160t. What I'm going to do is move the 384 to the other side by subtracting, and so I get negative 16t squared plus 160t minus 384. I always like to set quadratic equations to 0 so I can either factor to solve them or use the quadratic formula or complete the square, whatever method that you prefer to use. And then I want to make this easy on myself. And so if I see all these big numbers, I'm going to say, what's a common factor? I can just divide out of here. Because I have a 0 on the other side, I have an equation, I can just divide everything. In this case, I can divide everything by negative 16. I tried that to make sure that it worked. It may be that you can only divide by 4 or divide by 8 or something, but you could try to get those numbers to be smaller if you can. 0 divided by anything, still 0. Over here we have t squared. 160 divided by negative 16 is negative 10. And 384 divided by 16, they're both negatives, makes that positive, and that gives us positive 24. And then we just want to factor that. And there's a bunch of different factors for 24, but we want them both to be negative because we have a bunch of negatives, but over here we have a positive. So an only way for that to work is to have negative 4 and negative 6. Then I'm going to set both of those equal to 0. T minus 4 equals 0 and t minus 6 equals 0. And that tells me t is 4 or t is 6. Does it make sense for us to get two answers? Well, yeah. Let's say that this is our height of 384. If we look over here, there's two different times when it hits that height, right? It goes up, it hits that, it goes up a little higher, it comes back and hits that height again. So it totally makes sense when we have a projectile that we can have something that hits the same height twice in that period. And then it says, when will the rocket strike the ground? And it hits the ground when the height is 0. So instead of having 384, we just put 0 in there. And then I'm going to do the same thing as far as dividing to get my numbers to be a little easier. I'm just going to divide everything by negative 16 again. Again, this is something you really don't have to do, but if you're trying to factor with all these huge numbers, it's going to be so much more difficult. So if you can make it easier on yourself, do that and then start to factor. Now I can see I have a common factor of t in here, and I have t, and I have t minus 10. And so was at 0 when it started. Yeah, that's not that interesting because we already knew that. But we also know that after 10 seconds, it comes back and hits the ground. So 10 seconds afterwards, when the rocket hits the ground is 10 seconds after. And when it's at this height is at 4 seconds and 6 seconds because it has both of those in there. So that's where factoring kind of really comes in handy, and it's kind of two different types of factoring there, where here we're just taking out a common factor, here we're having to factor trinomials. All right, have a fantastic day, and we'll talk to you next time.